In this video, we're going to talk about how to write the equation of an ellipse with some given characteristics. And we are going to start with this first example. We're going to write the equation for an ellipse with vertices at 0, 0 and 6, 0 with a minor axis of length 4. So, again, I always think it's a good idea to start by drawing a picture. Let's get a sketch, see what this thing looks like. Well, I have a vertex. Let me switch to red. I have a vertex at the origin. I have a vertex at 3, 4, 5, at 6, 0. I have a minor axis of length 4. Now the minor axis is going to be in the middle of these, and let me see. So here's a vertex, here's a vertex. The center of my ellipse is going to have the coordinates 3, 0. I have a minor axis of length 4. And I have enough at this point to sketch my ellipse. My ellipse will look something along those lines. Now, my minor axis has a length 4, which means this is going to be from the center to that minor vertice. Has a length of 2. Here's a length of 2. I have a length of 3 and a length of 3 going horizontally along the major axis, which I'm going to highlight in blue. And I have enough to write my equation, so let's do this. The equation in general for an ellipse is x minus h quantity squared over the distance from the center to the vertex squared plus y minus k quantity squared and the distance from the center up to the minor vertex in this case, and this equals 1. So I can substitute my values. When I substitute my values, I end up with x minus 3 quantity squared over 3 squared is 9 plus y. There is no vertical shifting for my ellipse, so this is just going to be y squared over 2 squared is 4, and this equals 1. All right, let's do another one. This time we're going to do an ellipse with vertices at -1, -3, and -1, +3. So here are my vertices with a foci at -1, 2. So let's sketch the situation, see what we're looking at here. -1, -3 puts a vertex here. -1, +3 puts a vertex here. I have a foci at -1, 2. I'm going to notate that that's a foci by drawing a little F. I can see the center of my ellipse is going to be here, and the center is going to have the coordinates -1, 0. Because ellipses are symmetric, if I have a foci 1 unit below the higher vertex, I'm going to have another foci here as well. We don't need that to write the equation, but it's never a bad idea to be thorough. Now the question that I have is, how wide is this ellipse going to be? And that's the thing that we don't know. What I do know is the vertex and the foci all are going to lie on, or I should say the vertices, they're going to lie on the major axis. And that is important. I'm trying to erase this. You're not erasing. Okay, here we go. Okay. Oh my gosh. Sorry. Okay, there we go. So the foci lie on the major axis. Which tells me that my ellipse is going to be taller than it is wide. So let's fill in what we have. The format is x minus my horizontal shift. That's going to be x plus 1 quantity squared over, I like to say the width squared, but really it's from the center to the widest part, plus y minus my vertical shift, which in this case there was no vertical shift, so this is just going to be y squared, over the vertical distance from the center to the vertex is 3. This is going to be over 3 squared, and this equals 1. What we're missing is the width of this ellipse. So, I do know that the distance between the center, from the center to the focus, is 2 units. And this helps me because I have this formula that says c squared, which in this case is going to be 2 squared, equals it's either a squared minus b squared or b squared minus a squared. In this case, it's that. And the thing that I need you to know is it's going to be the larger distance minus the smaller distance. The b value in this case is going to be 3, which is the distance from the center to the vertex. So this is going to be 3 squared minus a squared. That's going to be 4 equals 9 minus a squared. I end up with a squared equals 5. A is about, or A is rad 5, which is approximately 2.2. So if I'm going to sketch this, let me just erase this part here. I know I'm going about 2.2 in either direction widthwise from the center, and that is going to make my ellipse look something like that. Again, I went out 2.2 units from the center in either direction. Going back to my formula here, in my formula, rad 5 squared, which is this horizontal distance, that is going to be, when I square that, that's going to be 5. So I have x plus 1 quantity squared over 5 plus y squared over 9 equals 1. And that will be the equation of our ellipse. Thank you. Have a great day.